I'm now preparing to embark on the Fireworking 201 course. I wasn't necessarily pondering doing an introduction to Fireworking 201, but then upon thinking about it, I thought it might be useful just to get started on the right foot in Fireworking 201. In Fireworking 101, we covered 17 or so lessons, many of them basic lessons in materials and techniques used in general in fireworking, and then also focusing on some basic devices like gerbs and wheels and chromatropes. Many of those basic techniques will be built upon in Fireworking 201. I'm not necessarily going to video in detail each of those basic steps as I work on some of the devices I'm going to be covering in Fireworking 201. That would make a lot of this redundant and would make for very lengthy videos. So let's say I mention weighing the chemicals or screen mixing the chemicals for some of these devices we're going to be working on in 201. I'm just going to mention that, and then I'm going to show the finished product from using that step, such as screen mixing. So don't skip Fireworking 101 and jump right into Fireworking 201 unless you have a really good grasp of all of these basic steps. It's going to be necessary to know how to weigh, how to pulverize, how to screen mix compositions, how to tie clove hitches, how to do some hand ramming, how to do some basic fusing. So if you haven't practiced the techniques in Fireworking 101, at least as you do prepare to apply those techniques to the projects in Fireworking 201, it'd be beneficial to go back and review some of the essential basic lessons in Fireworking 101. In addition to the basic chemicals we use in Fireworking 101, we're going to add a couple more simple ones: 80 mesh, charcoal, and hot, fine, air float black powder charcoal such as willow or paulownia. The Fireworks cookbook is stocking specifically for use in Fireworking 201. They're stocking a hot air float paulownia charcoal that's already been ball milled, does not need to be ball milled anymore. They also stock the fine pulverized potassium nitrate. So once again, in Fireworking 201, although we're going to be tackling and demoing some relatively complex devices, we're still going to be doing that without any complex, expensive machinery. We're not going to need a ball mill because we can purchase pulverized fine potassium nitrate and airfloat charcoal and hot black powder airfloat charcoal. We're not going to need a press, an arbor press or hydraulic press, because we're going to still rely on hand ramming. We're not going to need high quality New England paper tubes yet, because we're not going to be doing any pressing. We can still use the relatively inexpensive pulpy walled tubes that Caleb at Woody's Rocks is stocking. So we are not going to be using any more advanced, complex, expensive machinery or tools. We're going to still be using the basic tool set that we used in Fireworking 101, the same basic chemicals with the addition of those two charcoals. So once again, although we're going to be making some complex devices, we're not going to be introducing expensive processes, tooling, machinery into Fireworking 201. I still want to keep this simple, inexpensive, and focus on the basics in Fireworking 201. Then when we get that down, we get aerial mines down, some basic aerial shells down, both cylindrical and ball shells. We get some basic rocket motors and rocket headings down. That then opens a wide world of fireworking to us, where we can advance into different rocket motor effects. For example, we can advance into different type of stars, colored stars, rolled stars. We can advance into different insert components into aerial shells, such as crossets and comets and go-getters. Once we get these basics down, the wide world of fireworking opens up to us, and we can really take one step at a time into much more advanced projects, devices, tooling, machinery. Then, you know, a lifetime of fireworking opens up if we get the basics down and if we have the inclination to pursue it to those kind of levels. In Fireworking 201, I'm going to progress through some basic devices, components that build on each other, once again, just like I did in Fireworking 101. We've already made black match. For some of the processes in Fireworking 201, we'll want to make some thin single strand black match, which would be half the diameter of what we made before in Fireworking 101. That comes in handy for fusing rocket motors, for cross-matching time fuse if we're using time fuse in aerial shells. It can be handy to have a finer, a thinner diameter black match. So one of the first steps you could take, using the same process as shown in Fireworking 101, but using a single strand of the 8-ply cotton string, go ahead and make some thinner black match. That's going to come in useful in some of these projects, and I'll show that being used. Then we're going to learn how to make and test black powder. Black powder for lifting aerial shells, for lifting aerial mines, for bursting aerial shells, for bursting rocket headings. Black powder for ramming into tubes to make the time fuse, rammed split black powder time fuse for some aerial shells is going to be an essential component. They call black powder the heart or the lifeblood of fireworks, and making good, powerful black powder, testing it to verify that it is good and powerful and useful for our purposes, is one of the first essential steps to advancing into some more complex devices. We're going to make a little cubic maroon, a ground salute using black powder, not flash powder, so it's a relatively safe device, but it makes a good satisfying boom. Because let's face it, one of the first things we do when we get into fireworking is we want to make a good boom. So we'll make a good black powder maroon using the powerful hot black powder that we make in the black powder projects. Where I'm going to show how to make stars, both pump stars and cut stars, to use in our mines, our aerial shells, our rocket headings. Those two basic techniques can be used to make stars, aerial fireworks stars. We're going to focus on charcoal stars with or without some metal components, fine metal in them for metal sparks. Cutting stars and pumping stars are good, easy ways to make stars, and it doesn't require any expensive equipment. I'll show using a star gun to test our black powder and our stars, especially the stars, to see how they perform in the air. I'll go over some basic electric firing and firing systems and some release points for wheels and girondolas, just as a brief introduction to electric firing. Then we will use the stars and the black powder to create an aerial fireworks mine. As I mentioned, we'll ram some spillets for timing in aerial fireworks shells, and then we will make aerial fireworks shells using both the pump stars and the cut stars. We'll start off with a simple cylindrical aerial fireworks shell. And then I'll show making a hand-rammed rocket motor, charcoal-tailed hand-rammed rocket motor, the option of adding some metal sparks into the delay increment in those rocket motors for a metal spark effect in the sky. And we'll show how to use the cylindrical aerial shells, the same essential construction without a time delay in it, as rocket headings on those rocket motors, and how to assemble a complete rocket motor, heading, stick, fusing, even some electric firing into a complete rocket. And then I'll add a couple, I also want to show the construction of a 4-inch ball shell as an introduction to paper ball shell construction, which leads to a whole world of spherical paper ball shells and different effects that can be achieved with them. Then I'm also going to show a tourbillon, a flying tourbillon, which is essentially a spin-stabilized flying rocket motor It's like a rocket motor but different. So a flying aerial tourbillon, and then also basic girondola construction. Girondolas lead into a combination of rockets and shells and headings and fusing, into a more complex device that, gosh, they can provide a lifetime of satisfaction. So those are the type of projects we'll tackle in Fireworking 201. Once again, starting with the essential techniques and skills we learned in Fireworking 101 and leading into the slightly more complex and yet simple, inexpensive devices that I just listed, and then opening up into the wonderful wide world of fireworking, which can challenge us for a lifetime. So that's a brief introduction into Fireworking 201. The next first project will be actually making some black powder, which is a pretty simple project, very satisfying, and leads into some very useful applications for that black powder that we'll make.